Alright, so in this lesson we're going to learn how to differentiate using tables, graphs, and symbolic differentiation. So quite often on the AP exam you will be given tables, graphs, different things, and then you will have to find a derivative. Okay, so we have all of these different tools in our toolbox to find a derivative. We know that a derivative in its most basic form is the slope of the tangent line. So we have our slope formula. Then we have our power rule, which is kind of the shortcut to take the derivative. Then you have all of these other rules, the product rule, quotient rule, and now you just learn the chain rule. So we are going to choose from each of these tools in our toolbox to find these derivatives. So let's look at example 1. The table gives the values of a function that is differentiable on the interval from 0 to 1. Find f prime of 0.1. So again, you have to figure out which tool to use in your toolbox. We're not given an equation, so we can't use the power, product, quotient, or chain rule. The only thing that's left is our slope formula. So we can say that f prime of 0.1 is equal to, and whenever you take the slope you want 2 points, so I'm going to take these 2 coordinate points right here. So we can have f of 0.2 minus f of 0.1 over 0.2 minus 0.1. Okay, so we would have 0.433 minus 0.261 all over 0.1. If you were to plug that into your calculator and don't round in the middle, you would get 1.72. And that is the approximation, or I guess it would be an approximation of your derivative at 0.1. So now let's look at example 2. This is what they mean by symbolic differentiation. So you are given a table of values, so you have f, f prime, g, and g prime, and you need to find each of the following derivatives at x equals 2. So I think these are quite fun because they are requiring you to use all the different rules. Power rule, product, quotient, and chain. If you look at the first one, to find h prime of x, this is our chain rule. So remember, it's the derivative of the outside times the derivative of the inside. And if we want it at x equals 2, then it is f prime of g of 2 times g prime of 2. So g of 2 is 3. G prime of 2 is negative 1. Okay, so I can have f prime of 3 and then times negative 1. Well, f prime of 3 is negative 2. So I have negative 2 times negative 1, which is equal to 2. Let's look at b. So we have k of x is equal to f of x cubed. This case, if we wanted to find the derivative, we would need to use the power rule, power rule and chain rule. Okay, so we take the derivative of the outside, so we would have 3 times f of x squared, and then we need the derivative of the inside, so f prime. If we were to find k prime of 2, we would have 3 times f of 2 squared times f prime of 2. So on our table here, f of 2 is negative 4, f prime of 2 is 8. So we would have 3 times negative 4 squared times 8. And all of that would equal 384. The next one here, It is a combination of product rule and chain rule. So we have the product because we have the multiplication. And then whenever we try to take the derivative of that g function, we would need to use the chain rule. So our derivative here, so product rule is the first times the derivative of the second. So I have g prime of 2x times the derivative of the inside, which is 2. So I have the first times the derivative of the second plus the second times the derivative of the first. And if I wanted p prime of 2, I would have f of 2 times g prime of 4 times 2 plus g of 4 f prime of 2. So f of 2 is negative 4, g prime of 4 is 3, g of 4 is 2, and then f prime of 2 is 8. So we would have negative 4 times 3 times 2 plus 2 times 8. And all of this is equal to negative 8. Our last one here is a combination of quotient rule and chain rule. So if I wanted r prime, remember quotient rule, it's low, d high, so the derivative of the top, that's where the chain rule would come in, minus high, d low, so I'd have g prime of x, and it is over low squared. So if I wanted r prime of 2, I would have g of 2 f prime of 4 times 2 minus f of 4 g prime of 2 all over g of 2 squared. And I'm running out of room, so I'm just going to give you the answer. It is negative 6 over 9, which reduces to negative 2 over 3. Alright, on this next page we're given a graph and we need to find each of these derivatives. So let h of x equal f of g of x, where the graphs of f and g are shown at right. Estimate each derivative and justify your analysis algebraically. So I have actually highlighted these graphs in the different colors just because it can kind of get confusing trying to distinguish the two. So first we want g prime of 3. So if you look at 3 on your graph of g, which is the purple one, if we were to estimate that derivative, so that tangent line, I don't have a ruler on this thing, but I would estimate that the slope of that tangent line is negative 1/2. Okay, and so justify your analysis algebraically. If we were to use the slope function, so this coordinate point here is 3, 5. This coordinate point here is 5, 4. So we can use 5 minus 4 over 3 minus 5. I am so sorry about my dog. She snores so loud. So 5 minus 4 is 1. 3 minus 5 is negative 2, which will give you negative 1/2. So the next one we have f prime of g of 3. So first we need to find g of 3, which is 5. Then we need f prime of 5. So if you look on your graph of f, we need the derivative at that point, which is undefined because we have a cusp or a corner. Okay, so we cannot take the derivative at that point because it is a sharp corner. So now let's look at h prime of 3. So h is equal to f of g of x. So if I want the derivative, actually let me write it up here. So h prime, this is the chain rule. So the derivative of the outside times the derivative of the inside. So if I wanted h prime of 3, I would need, so f prime of g of 3 times g prime of 3. Okay, so g of 3 on your graph here is 5. So f prime of 5 times g prime of 3. Since f prime of 5 is undefined, then h prime of 3 is undefined as well. And this is because f prime of 5 is undefined. So now let's look at f prime of 7. So on the graph of f at 7, so that point right there, this is a straight line. It's very simple to calculate the slope between 2 points. So let's use this point right here, which is 5, 6, and 7, 5. So if I were to calculate the slope between those 2 points, so 5 minus 6 over 7 minus 5, so 5 minus 6 is -1, 7 minus 5 is 2, so my slope is -1/2, which makes sense because you would go down 1 to the right 2. So now let's look at g prime of f of 7. So f of 7 is going to be 5, so then we would have g prime of 5. If you look on your graph of g prime, I'd say that that coordinate point right there is probably 5 and 3.5. So you can use your slope formula to estimate this derivative. I'm going to go ahead and use this other point here, which is 3, 5. So if I were to use my slope formula, so 3.5 minus 5 over 5 minus 3, you would get 1.5 over -2, which fancy turns out to -3/4. Okay, so that would be your slope of g prime, or yeah, the slope of the tangent line at 5. Last but not least, let's look at h prime of 7. So again, up there I have my derivative already, so h prime of 7 would be f prime of g of 7 times g prime of 7. So if you look on your graph here, g of 7 is right there. I would estimate that to be about 2.75. So f prime of 2.75, and then g prime of 7 over here. Let's see, what would you say? Probably about 1/4. If I had a ruler on this notes app here, it would look better, but that slope is about 1/4. So then f prime of 2.75. So if we look at the graph of f, 2.75 is probably about right there. So luckily this is a straight line. If you look at the slope of this line here, down 2 to the right 1, so this is -2 times 1/4, which ends up being -1/2. So I know these can get a little confusing, but this is how you find the derivative symbolically. Again, AP questions love to ask you these given tables and graphs. Like always, let me know if you have any questions.